Hey everyone, welcome. This is Aurora and family. This is my husband Al.
I'm Al.
And this is Ben. And we are bringing to you a presentation for tonight with the Central Coast Astronomical Society. Would you guys like to go stargazing with us? What do you guys think? You want to go stargazing?
Let's do it.
Oh, yeah.
Let's go. We actually have a special pre-show for you today. And actually it took these guys to help me put it together. So I'm really grateful for that they were able to help us out for tonight. We're going to have so much fun tonight. So I know I'm a little bit early. For those of you who are early birds, I have some extra special content. We actually have a lot of really cool things happening tonight. The first thing before we get started, I want to make sure that you have your handout for tonight. Now, this is right below the video that you clicked on in order to get to tonight's presentation. If you have it, that's great. This is something that Kent put together along with myself and Brian. You're going to meet Brian in just a minute. And you can write notes in this as we go through it. Or if you don't have it, you don't really need it for class. It's just something to have after our session is over. It kind of, it'll highlight a lot of the stuff that we're going to be talking about tonight. The other thing that you can have is the sky maps for the month. And this is available from skymaps.com. It's free. And you just go and pick your hemisphere. And this is a really easy way to print this out. How this works is you simply put it over your head and look, line up the north and south. And what you see here is what's going to be projected against the night sky. So that skymaps.com is a really great resource. On the back of that chart, you'll also see what's up in the sky tonight. You can look at those things as well. So that's super fun. So also joining us tonight, there is a number of astronomers who are in the chat. So if you have any questions during our presentation tonight, feel free to type them in so they can answer your questions during the class session tonight. We will be answering questions throughout class. There's a link right below. Do you see it? There is a phone number. Don't call it. It's just for texting. So if you have questions, you can text that number or you can send in an email to questions@centralcoastastronomy.org. Okay, so we're gonna be joined by a special guest. His name is Alex McConaughey, and he is from the Riverside Astronomical Society. And I've actually asked him to share with us one of the objects that we're gonna go into depth later in this session tonight. But he actually went out into the field, took a few pictures a few nights ago, and he put together a special presentation that he wants to share with you. So this is kind of a like the clubs working together. What do you call that?
Cooperation.
Collaboration. That was the word. Collaboration. And so they, so anyway, so I'm really excited that he's going to be joining us tonight. Are you guys ready for his little quick presentation? Okay, so it's just a few minutes long. He's only going to be with us just for a couple of minutes that he had to spare tonight. So we're going to go ahead and I'm going to show you the telescope that he used to take this to take the images he's going to share with you. And he'll share with you a little bit of background information. Are you ready? Okay, so hang on just a second and let me see if I can call him. Hang on just a second. Let me get him up. And give me just a second here. All right, Alex. Alex, are you there? Hey, Alex, it's Aurora. Are you there?
Hi, everybody. Thanks, Aurora, for having me here tonight so I could talk about a great big open cluster, M67. It's also called the King Cobra Open Cluster. But for the life of me, I really don't know why.
Uh-oh, it sounds like we lost Alex. Hang on just a second.
It's easy enough to find if you go hunting for it. On an April night, you get Sirius down here, and you can see Orion over here and Leo the Lion's up here. And you call up your program and you tell it you want to go looking for M67. There it is, right along the ecliptic with Cancer. And as you zoom in on it a little bit, you can't see much at first, and then your binoculars maybe pick up a cluster, and then you keep going, maybe get a big telescope on it, and you'll find out a whole lot more to look at.
Oh, cool.
So it's easy enough to find. Now, if you go and put a long exposure telescope on it, you'll see lots and lots of stars, and they'll come out in different colors, different shapes, or different sizes, and it's really a very pretty object.
Nice.
This is a star cluster. It's called a star cluster. Well, Duh, it's a big cluster of stars. It's called an open star cluster because you can see there's lots of room in between the stars. There are lots of open star clusters out there. Here's 3 of them right here. And you'll notice they all look a little different, but the thing that you'll all see in all of them is that there are lots of stars collected together.
Mm-hmm.
Now, there's another kind of star cluster called a globular star cluster because it forms a globe. And these beasts are very different. A globular star cluster is not at all like these open star clusters. And we're going to talk about open star clusters and what makes them what they are. M67 is an open star cluster. It's on Charles Messier's list of fuzzy objects. It's the number 67th one on there. It's in the constellation Cancer. It wasn't discovered for the first time by Charles Messier, but by Johann Euler, who first recorded it in 1799.
Wow.
The light from M67 has been traveling towards Earth for about 2,700 years at, of course, the speed of light. It's about 10 years across from one side of the star cluster to the other. Now, not all the stars here are in the cluster. Some of them are background stars and some of them are outside. But this is the area of the cluster in general. It's about 4 billion years old, and this makes it one of the older star clusters that we know about. Not the oldest, but it's old. And there's about 500 stars altogether. 100 of them are pretty much like our sun, to the point that scientists have actually watched sunspots cross some of the suns up there, some of the stars up there, and by using light curves and things, and found out that it takes about 26 days for these suns that are like our own sun to spin around. So they're pretty much about the same thing as we've got. There are also many red giants, and altogether there's about 1,200 solar masses. That's the mass of our sun, the weight of our sun. There's about 1,200 of them in that collection of stars up there. And they represent stars of various stages of stellar life.
Mm-hmm.
Now, what do I mean by various stages of stellar life? Well, stars have a life. See this big cloud of gas? It's part of the M42, M43 complex over here. Okay, right in here you'll see some stars. Those stars are actually forming right now from condensing gas. In a million years, 2 million years, something, there'll still be some gas around, but not as much as there was before. And then you get to an older star cluster like this one, and all the gas is pretty much gone. It's been collected by the stars or it's been driven away. The stars start to drift away from each other then, and eventually those stars dissipate. There's no more star cluster. All the stars separate out and go their own merry ways. Just like kids in the house. They're born, they're dusty, they're dirty. They get themselves cleaned up and off they go. Another interesting thing. Notice the Big Dipper here?
Yeah.
Okay. Some of your best friends live very near a star cluster. The Big Dipper is actually part of a star cluster. Now, we're not part of that star cluster. It's a little bit, it was formed about 300 million years ago, and we were about 4 billion years ago. So star clusters are formed together at the same time. All the stars in them form together at the same time and have a life. They live together like a family, okay, and grow up together. But we are not part of the Big Dipper. I don't mean to say that, but we're very close to being in a star cluster that's part of the Ursa Major moving group, and that's a star cluster. I hope you enjoyed that little bit of information about star clusters.
Yes.
And I hope to come back someday.
Thank you so much, Alex. Thank you. If you guys enjoyed that, go ahead and put Alex a little note. He just He just was going to blip in for a couple of minutes before we start our show. Are you guys ready to get started? Should we start?
Yeah. Oh, yeah.
Oh, yeah.
Oh, yeah.
All right. Well, let's go ahead and get started. So, hello, everyone, and welcome. My name is Aurora with Central Coast Astronomical Society. This is my husband, Al, who bought me my very first telescope 15 plus years ago and took it apart and hid it all over the house. And then I had to find it and put it back together. So, thank you. And so this is, thank you. And so this is our son, Ben, who is now a freshman. And what's your major, Ben?
Manufacturing engineering.
Yeah, so we're excited, and he loves astronomy too, so he wanted to join us. All right, so we are going to get started, and just real quick, there's a link that's below. Do you see it right there? It says if you have any questions, you can email us. You can email questions@centralcoastastronomy.org. You can also text it. Please don't call that number. There's no one there to answer it, but if you're connecting and there's no connecting in a way where there's no chat box or anything like that, you can go ahead and text that number, your questions, at any time during tonight's presentation, and we'll be able to answer those questions during our live class or live session for tonight. We plan to be together for an hour, maybe just a few minutes more, and I'm really, really excited. We have a number of astronomers on with us tonight. You've already met Alex. You're about to meet two more. I'm going to bring Brian on, and then you're going to meet Kent. We also have some astronomers who are busily answering all your questions in the comments section, so please feel free to ask them any questions you have as well, so they can answer those as we go through our session tonight. Okay, so I'm actually going to make that questions, that little box disappear, so please write that down on your handout. There was a handout that goes with tonight's presentation. Make sure you have it. This was underneath the video. Brian, is it underneath, below, in front of? Somewhere. It's around the video.
Yes. The question link, you mean?
Yeah, or no, where the handout is.
Oh, yes. I tagged that pinned that to the top of the live chat.
Oh, okay, perfect. Thank you. It's just really a recap of what we're going to be talking about. So when our session is over, you can go ahead and you can take notes as we're doing it, or just wait till afterwards, print it out for yourself. And so that's something a little extra. Kent himself put that together. So I'm really excited that he is doing that for us. So thank you. Okay, so let me go ahead and introduce Brian to you. Brian, you are over here. Let's have everyone say hi to you. Go ahead, Brian.
Hi. Hello, Aurora and family and friends and everyone online. Glad you could join us tonight. We're looking forward to a really exciting time. I and fellow astronomers will be online on the chat answering your questions anytime, so keep them coming. I want to point out too, sometimes people notice that they'll try to go outside and watch this event while they're looking at the night sky. Well, if you're still in California, no luck yet. It's still slightly sunny out there. Maybe not sunny, at least not completely dark. But something that we find is good to do is the first time, have that printout, watch it inside, keep notes, and then once it's fully dark, go outside with that handout and a red flashlight, and then listen to the presentation because it's available as a recording right away. And that way you're getting it the second time. It'll be a lot easier to follow Aurora and Kent's directions on finding the objects if you're listening while you're looking at the night sky. So have fun.
Awesome. Thank you. Thank you. All right. So we are going to go ahead and get started. You guys ready? Okay. So in order to do our presentation for this evening, we have to bring on Kent. So Kent, are you there? Hello?
I'm there, Aurora.
Hi, Kent.
Hello, everybody.
Hi. Hello. For those of you who are brand new, Kent is only going to be with us via audio, but I do want to show you just because he's super amazing, and also because we really want just to show you my screen. So most of the time it's going to look like this, where we point things out. And also, just to introduce Kent to you, I've known Kent as soon as I put that telescope together. And he's been the celestial advisor for Central Coast Astronomy for decades. Is that right, Kent?
Something like that.
Something like that. So anytime we had a question when we were stargazing, we would always just say, "Hey, Kent," and he would just automatically know what it was. So he's our resource for tonight. So he is an amazing resource to have. So I'm going to go ahead and share a screen with you. There we go. So Kent, I've got a picture of you here. Do you want to let us know what we're looking at here?
Oh, okay. Now I've got the picture there. The forward picture is me with my old C8. Mm-hmm. I used that for about 13 years before I went to the 20-inch. And then the picture,
sorry, go ahead.
The picture up in the corner is from Western Australia when I made a trip there in way early 1999. I'm wearing the vest. I'm to the far left. My C8 is just barely visible on the far left there. Different type of tripod. That's Mr. Fuji next from the left. The next, he's standing there. He's the actual owner. He has 2 observatories on the property. It's actually a wheat field in a place called Urcoin, Western Australia. I think Urcoin's maybe got 50 people in it, something like that.
Wow.
Yeah, maybe more now because it's been like 15 years since I've been there. The next gentleman was a friend of Mr. Akira Fuji's. And then the final gentleman on the right sitting down, he's from Sweden. His name's Timo Kahara. And he wrote an article in the Web Society that got me going or actually got me wanting to go to Western Australia to see the other side of the sky. And you can see how flat the land is there. It just goes off into the distance.
Wow, there's like no mountains at all. Now this is the
yeah,
scope
I
you
mean,
took.
what we call foothills, they would call the great, mountainous range.
Yes.
The highest point in Australia is under 8,000 feet. So
wow.
they really don't have mountains like we do.
No.
And, the only problem is it's so flat. If the wind starts blowing on one side of the state, it just keeps on going.
Oh, no.
So at times it was very windy out there.
I bet. Now, this is the big scope that you took, right?
Yeah, the one in the upper left is was a prototype breakdown structure that I air freighted to Perth, Australia, to a friend there, and it's a prototype. The one down in the middle at the bottom, that's my regular one. I kept the same mirror because the mirror costs more than anything else, and in fact, over to the upper right, you can see me with the special case for shipping the mirror. And that mirror would come back and forth. When I'd leave Australia, it would come with me, being air freighted back to California. So it went back and forth a few times. I took like 3 trips with the 20-inch, and then at the end, everything got packed up and sent back to LAX.
Oh, wow.
And I finished my survey I was trying to do on planetary nebula, and I ran out of money also, which was another. It's not cheap to do something like that, but it was like a trip of a lifetime. So
yeah, and now you get
no
to share.
Regrets there.
I know, and now you get to share some of that knowledge with the rest of us. So we're very grateful. So yeah. Now we also we have the moon this month, which is favorable for this weekend. Is that right?
Yeah. In fact, Monday is new moon, so you can go all the way to like the 14th and 15th without any problems. If you're patient, you can go for the 16th. And starts getting a little bit larger for the next weekend. But yeah, right now, tonight will be great. Tomorrow night, Monday, Wednesday, Thursday, it's just a really nice time right now if you want to do some, really nice viewing with the moon out of the way.
Nice. All right. Well, Kent, are you ready to get going? Should we start with our first object?
Yeah, let's start with, the first constellation, which is Cancer.
Okay.
And I don't know if you want to run it up there on the,
I sure
the stellarium.
do. I sure do. So let me go ahead and highlight the one we're going to use. There we go. Okay, so tell us about Cancer.
Okay, Cancer is an ancient Greek zodiacal constellation, and by zodiacal, there's 12 of them. They're the constellations that the planets move through. The sun, the moon, etc., go through the zodiacal constellations. And unfortunately, Cancer's the most pitiful one of all of them. I mean, it has no really bright stars in it, but they can be seen with a naked eye as long as you've got a good dark sight. And, it's also got a little bit of mythology. It's, Cancer is the crab. And Hera, who was the wife of Zeus, always was trying to kill Hercules. So she sent the crab there to try and kill off Hercules, and the crab lost big time. And she felt sorry about it, so she put the crab in the heavens. And even though it failed to kill Hercules, it got rewarded. And so that's a mythology behind Cancer, or the crab.
Okay, great. Now, I should mention to everyone, our goal tonight is to make it so we can show you how to do practical astronomy. So after tonight's session, you should be able to go outside, look up, know where to find it, and know what you're looking at. So I may be going over and over a few times during our presentation tonight about how to find certain things. So let's do it with this one. Kent, show me, how do we find
this one?
How do we find this one?
Cancer is up really high now.
Mm-hmm.
So it's between Leo and Gemini.
Yeah.
And so that's probably the easiest way to go. Is you've got Castor and Pollux. We've talked about those on previous shows.
Mm-hmm.
And we're going to talk about Leo tonight,
Yes.
although I think we talked about Leo a long time ago last year.
We did.
But you can see how Cancer's kind of wedged between the Lion and the Twins there.
Mm-hmm.
And it's almost, I think, overhead right now once it gets dark. So hopefully you have a flexible neck, or you have like a lounge or chair or something you can lean back in easily to look up. And
yes. And one thing that Ken, if I could interrupt you for a second, one thing that a lot of people can find is Orion. So if we go outside here, unfortunately, there's no labels or sticks or anything connecting them. But if they can find Orion, can you show us where to find Castor and Pollux?
Okay, if you
Orion.
can find Orion there, just kind of go from, I don't know if you remember Rigel and Betelgeuse.
Mm-hmm.
Those are the two brightest stars in Orion. One's the foot of Orion, the other one's the shoulder. Just draw a straight line, and that'll take you towards that pair, Castor and Pollux.
Okay, great.
So that'll get you pretty near there. And then to get over to Leo, you just kind of move east from those. And in fact, Regulus is the brightest star in Leo, and we'll talk about that one tonight.
Mm-hmm. Okay, great.
And then right in between them is that pitiful faint constellation.
Let's see if we did it. There we go.
Let's talk about M44, which is
great.
actually a naked eye open cluster. To the naked eye, it just looks like a little cloud, and it goes way, way back. Before recorded history, probably people were using it as a weather indicator. If you could see the little cloud there, it meant you're going to have clear weather. If you couldn't see it, it meant stormy weather was coming.
Oh, wow.
And it was recorded by Aratus in 260 BC he just referred to it as the small nebula. Mm-hmm. And then Bayer in 1603, he cataloged it as a Greek letter, which is epsilon, in his atlas that was called Uranometria, and that's the first full sky atlas that was ever produced. And Galileo, when he got the telescope and started looking around, he resolved M44 into stars in 1609. So he was able to say, hey, that's a cluster of stars instead of being like a little cloud. So it's got quite a bit of history behind it there.
Nice. Okay, great. Now, it's also got another name, right, besides the beehive?
Well, it's called, the oldest name is called the Precept.
Okay.
And if you can go back to the wide field picture of the constellation, see how there's a bright star to the upper left, and a bright star also to the lower, actually right straight below those two stars there. Mm-hmm. Let's see, the upper one is called the Northern Donkey, and the lower one is called the Southern Donkey. And the old name for the cluster is the Precept, which is a manger that has fodder in it or food for the animals.
Oh,
So you got
wow.
2 hungry donkeys, guarding the manger there. Another nickname is the Beehive, which it's like the state cluster for Utah, because a beehive is a big thing
Hmm.
for Utah. So that's another nickname.
Oh, wow.
Gu-
Okay.
Guess I should go into some of the specs. It's a large open cluster.
Okay.
It's 1.2 degrees across, has a visual magnitude of 3.1, so that's why you see it as like a little fuzzy spot. It's only 610 light years away, has about, a little over 200 member stars, and has an age range of somewhere between 500 and 700 million years. Um, the northern donkey is actually given the gamma letter, Gamma Canceri, and it's actually called Acilius boreas.
Hmm.
Boreas always means northern.
Hmm.
Cilius is donkey, and yeah, that's the gamma one. And then the southern one is called Acilius australis, and australis always means southern, probably from Latin or something like that. And that's Delta Canceri. And so those are the two official names. Bayer gave them the Greek letters
Okay.
along with epsilon for M44.
Wow.
And you can see it's centrally located. It's about in the center of the constellation. If I don't know if you can pull up actually constellation boundaries on there, but
Yes, I can.
it is about right in the center of the constellation.
It's pretty faint. It's a red
Yeah,
box.
you can see it's kind of roughly rectangular,
Yeah.
and if you look at it, it's right about in the center there.
Mm-hmm.
And so it's pretty nice when you're looking for it. Look for those donkey stars, and you can get to it pretty easy.
Now there's another
And
one in Cancer too, right? There's
yeah, in fact, that's the one that Alex was talking about. He has really nice
yes.
presentation
Mm-hmm.
on open clusters, and that's M67. It's in southern Cancer, and it's about 25 arc minutes across. Got a visual magnitude of 6.9. So if you got really good eyesight, you might be able to pull it in at a dark site. It's about 2960 light years, so close to 3,000 light years out. Has about 700 members in that cluster, and it's a really old open cluster, as Alex mentioned. I've got an age of 3.7 billion years. What happens to a lot of open clusters, they lose members as they rotate around the galaxy. They're born, but they're still moving around the galaxy, and tidal forces strip off some of the outlying members, so it kind of gets eroded over time. So it's amazing that it's been able to hang on to that many stars after 3.7 billion years.
Yes.
Our sun is all by itself. It's
Mm-hmm.
what, 4.5 billion years or 5 billion years, and it doesn't have any brothers or sisters. They're all scattered throughout the galaxy,
Mm-hmm.
and that's what happens to most of the open clusters is they get eroded over time. Unlike the globulars that have so many stars to hold them together. I mean, you're talking instead of a few hundred stars, they've got thousands and thousands, tens of thousands of stars. So they can be like 10 billion years old and still hanging in there.
Wow.
So that's a really big difference. So it's unusual to have an open cluster that old at 3.7 billion years.
Yeah.
Yeah, let's see. Do I have any other neat information here? It's 1.75 degrees from Alpha Canceri, which is that star right next to it there, which is the alpha star. So if you can find the alpha star in Cancer, just kind of slide almost 2 degrees westward, and you'll stumble across it. It's also easily resolvable in binoculars. It's a nice binocular object.
Mm,
I remember not far away is the head of Hydra, which we had a big thing about Hydra last spring. And it was something where I'd look above the head of Hydra and there would be M67 with my binoculars.
Oh, wow. That's so
So
cool.
it's one way
Nice.
if you can find the head of Hydra, which is like a loop of stars,
Yeah, let
you
me
can
see if I
actually
get
go
it.
up above, and you're going to have to pull out quite a ways to get that head of
Hydra's
Hydra.
huge. Yes.
But you can see how you just go right up above the head.
Hmm.
Now we have a tilt to the screen there.
We do. It's because it's
There,
overhead.
that's more north and south like
Okay.
that. And so, but you can see how if you go right above that little loop of stars there, yeah, it's obvious in binoculars. So
Oh, nice.
that's one way to find it if you can find the head of Hydra.
Okay, great. Wait, before we go on, let me get rid of all the lines here. Let me shake it up a little bit. Okay, so we're going outside and we can really go in any direction. And basically we're going to be looking up. Oop, it looks like I didn't get rid of the sun. Let me get rid of the sun really quick. We'll make it a little later. There we go. Okay.
Yeah, that's more like when it gets dark now.
Yeah.
Is I notice Sirius still stands out really well, but it's flattening out because it's kind of getting low in the sky. And then you can see Orion over there, especially the belt, but they're starting to go away. I mean, they're winter constellations, and we're into the spring now. So
yeah, that's true. So to just
you know,
repeat I'm sorry, go ahead.
Oh, I'm sorry, but that's all I had to say about that.
Oh, okay. I was just going to repeat your directions just to be clear.
Oh,
You're just going to
okay.
take the foot of Orion and the shoulder of Orion, and then you're just going to keep going straight up till you see two really bright stars. This is Castor and Pollux. And
Right.
then we're going to talk about this one really soon. It looks like a backwards question mark or a sickle. And you basically look between the backwards question mark and Castor and Pollux, and you look in this area with your binoculars, and you'll be able to see the beehive. And actually,
I can see it right there.
You can
on
see
the
it right
graphic.
there. Yeah, it's right there. And then a little bit down here, let me put the lines back in so you can see it. Right around this area, you're going to look for M67. So right above this circlet here. So if I turn this off again, do you see the circlet? So right above this circlet, kind of right
I
in
can
this
just
area.
barely see it. Yeah, you circled it there.
Yeah, right in here.
There, it
There it
just
is.
blew it up. You got it.
Yeah, right in there. Okay, great. So perfect. So that I think that was all we had for Cancer, right?
Yeah.
Okay.
We just had the two open clusters for Cancer.
Okay.
Now Leo's next in line.
Let's go talk about Leo. Let's go find him.
Leo the Lion. It's an ancient Greek zodiacal constellation. Again, the planets move through Leo there. In fact, there, it actually kind of looks like a lion. You've got a head with a curve on it. You've got, Rigel is out there, kind of supposed to be a leg in front.
Oh, you mean
And
Regulus?
then you've got the triangle at the back, which is the hindquarters, and that star there is Deb Nola, which means tail of the lion.
Mm-hmm.
And so,
in
fact, there's
Leo. Yeah.
Yeah, tail of the lion. And in fact, there used to be a fluffy tuft at the end that they cut off and made into another constellation called Corona Borealis. Or not Corona Borealis.
Coma Berenices.
Coma Berenices. I'm sorry.
Yeah.
Yeah, the hair. You can see the hair there.
Mm-hmm.
And that's at that big naked eye open cluster there, Coma Berenices. I'm sorry. And so, it used to extend out to that, and that was a tuft at the end of the tail. And it got split off and made into its own constellation. But anyhow, I guess we should talk about Regulus.
Yes.
One thing about mythology, I think Leo represents the Namibian lion. It was one of Hercules' tasks to kill off the lion because it had an invulnerable hide. You'd try and stick it with a spear and it would bounce off, arrows would bounce off. I think Hercules strangled it to death or something like that.
No.
And so that was one of his 12 labors, was he skinned the lion and would wear its skin. So Hercules is often depicted wearing a lion skin, and I think that's from one of his 12th labors. So the lion didn't get the good side of the job there. Maybe Zeus felt bad and put it in the heavens. Who knows? But that's the mythology that I can remember about Leo the lion. And so the brightest star in Leo is Regulus. It's also called Alpha Leonis. Has a visual magnitude of 1.35, so it's fairly bright, easy naked eye star. Regulus is the 21st brightest star in the sky, excepting our sun. It's 79 light years distance, about 146 times brighter than our sun, and about 5 times the diameter. And you've got the little dwarf galaxy.
Oh, I was going to ask you, what is that?
Yeah, they're actually not far from Regulus. If you have a good-sized telescope and good conditions, move Regulus out of the field. It's kind of to the north there, and I think it may have gotten discovered on like Palomar survey photos. But it is a little galaxy, part of the local group. I think it orbits like the Milky Way or something like that.
Oh, how fun.
And there are guys that have seen it in their telescopes. You just have to make sure the brightness Regulus is moved out of the field.
Okay.
And I'm sure it just looks like a little fuzzy patch because you can see how dense the stars are there. I mean, it's not that big a galaxy. That's why they call it a dwarf.
Oh, I see.
And I think they call it Leo 1 because I think there may be some other ones that they've found in the future.
Interesting. Yeah, they do call it Leo 1. Wow, that's amazing. Okay, nice.
So that takes care of Leo.
Perfect.
Oh, let's point out the Psi as an asterism, which is the front part of Leo. That has to do with Regulus, and you go up to his front hindquarters, and then his neck and the curve that makes up the head forms kind of like a Psi, one of those curved farm instruments for chopping down wheat.
Yeah.
And they call it, it's an asterism, they call it the Psi on there. So that's kind of like, and it does kind of look like a Psi. You can see the handle and the curve of the blade there.
Yes.
And the reason I wanted to point that out is our next star, which is Gamma Leo, is kind of right in the middle of the Psi there.
Right there. Is this
one's
Gamma,
that's
right?
Gamma Leo right there. And Gamma Leo is a binary star. It's actually in the telescope. It resolves into like a nice close pair of orange stars. They're about 130 light years away. The brighter one has a visual magnitude of 2.37, where the fainter one has a visual magnitude of 3.64. Currently, they're separated about 4.73 arc seconds. William Herschel discovered this binary pair on February 11th, 1782. One orbit of the fainter one around the brighter one takes 554 years roughly, and it's a pretty object in my 8-inch scope. It's really a nice, even a 6-inch. If you get out somewhere dark and you have good seeing, it should show it up really nice. So I figured that's probably the prettiest double. That's a nice bright double for Leo.
Oh, nice. Okay, perfect. Now there's a couple galaxies in Leo, right, that we want to talk about?
Yeah, there's a couple. I mean, there's actually a whole mess, but we're going to go after some of the brighter ones.
All right.
The first one is, and actually they're a pair. There's M65 and M66. They're both at the same distance, about 32.8 light years. M65 is more to the west, if I remember correctly, in comparison to M66.
Okay.
M65 has a visual magnitude of 9.3 and a size of 9.8 arc minutes by 2.9 arc minutes. You can see it's kind of elongated.
Yeah.
I think you're got it on
There.
M60.
Sorry, wrong one.
There it is. Yeah, there's M65.
I have
It's
a better
about,
picture of it. How about this one? There you go.
okay, yeah. You can see how it's almost edge. It's like 74 degrees
Yeah.
to our line of sight. If it was 90 degrees, it'd be a line
Oh,
or
wow.
completely edge on. You can see it's getting there, but you can see a dark lane. That's actually a really good shot because you can see a dark lane running around on M65.
Yeah.
And both M65 and M66 were discovered by Charles Messier on March 1st, 1780. You can also see M65 and M66 with binoculars. If you have like 1050s, something like that, you should be able to pull them in.
Okay.
M66, well, actually, M65 is also about 2.6 degrees southeast of Theta Leonis. Remember when we were looking at that triangle that made up the hindquarters?
Yeah, let's look
There
at that.
it is. Yeah, you want to go for that. Yeah. Oh, wait. There it is. You just pulled away from it.
How's that? Is that okay?
Yeah. I was just pointing out the star Theta.
Okay. So
That's okay. That's Stebnola. There's Theta. And it's about, the galaxy is located about 2.6 degrees southeast. So it turns out everything's kind of twisted. It looks like you're going straight south, and it isn't. It actually needs to be rotated so that the Leo's belly is flat with respect to east and west.
Yeah.
And it would make the orientation of the two galaxies look better.
I know.
But anyhow, that's the information on M65.
Okay,
and M66 is actually about 20 arc minutes east of M65. So if you can find M65, M66 should be quite near. You just have to move it east. Again, you can see it in like 10x50 binoculars. We'll pull it in. And if you've got like an 8-inch scope or a 6-inch scope, go for low power. It should be real easy to pull in. There you go. You've got the belly of the lion pretty well east-west.
Yeah.
And
so right
anyhow,
in there.
It's right in there. Usually what I do is I get Theta in and then just move straight south till you can see there's one bright star and then like a little curve of stars. That little arc, I kind of go in front of that arc a little bit, and then I just circle around and pull it in.
Nice.
So that little arc there is useful for finding both of them, M65 and M66.
Okay, great.
And there's also another, you remember when you had it blown up and you could see M65 and M66? There's another galaxy, that edge on one with the little dark line through it.
Yes.
That's NGC 3628. Doesn't have a Messier number because it was faint enough for Messier didn't pull it in. And if you've got like a wide field eyepiece, low power on a small telescope, you should be able to pull in all three of them. They call them the Leo Trio. And that's something I remember, is that whole grouping of the three there.
Nice. And just to
photographers love it because you get three galaxies, they're all spirals, and that NGC one's an edge on with a dust lane running through it. So
that's awesome. And it's
really
again, they love to take pictures of it.
Yeah. People that are into astrophotography, they love taking the pictures of that one.
Nice. And just to reiterate, you just look for the backwards question mark or the scythe, and you just go right to the hindquarters. Here, if we
Yeah,
turn
that
off,
triangle is visible
see it.
to the naked eye that makes up the
Yeah,
hindquarters.
you'll see the
And
hindquarters
the end
here.
star there is Debnola, which is a tail lion.
Mm-hmm.
And so you go to the theta star and just drop down from the theta star
Yeah,
and right about in there. And
you'll find it.
if you have binoculars, it'll really draw you in, like 1050s.
Nice.
Will pull it in quite nicely.
Oh, and
And I think,
yeah, go ahead. Go ahead.
and that takes care of Leo.
Okay,
Unless you've got some
great.
questions.
I do have questions. We also had a request. They wanted to see who took the image of the one I was sharing. So let me share that image again. So these two images were taken by Peter, who has a telescope. And Brian, are you there? Did you just get communication from Peter about his telescope update?
Yes, so Peter actually has the ability to remote control his update, or remote control his telescope from inside his house now.
Whoa.
So
Nice.
that'll
Well,
be
that's nice. I notice he's got Thor's helmet. He's got the rosette.
Mm-hmm.
He's got the owl and the crab nebula in
Yes.
those photos. So.
Yeah, he's been doing amazing work. So he wanted to offer that when, not during the summer, of course, but during the winter, so we could be doing more live views. So good. All right, so we just have we're halfway through. We got 2 more constellations to go. Should we take a look?
We got the Lynx, which is a modern constellation.
Okay.
Created by Johannes Helvetius in 1687. There were a lot of spots that were kind of blank, and some of these more modern guys, made up new constellations. In fact, he bragged that the Lynx was so faint that you would need the eyesight of a lynx to see that constellation.
Well, that's not very useful.
So you got to have a good chart and a pair of binoculars if you want to just outline the Lynx there. It's kind of pitiful in some respects.
Here, let me get the Big Dipper in so people can kind of see how it's oriented.
There's the Big Dippers, right over there, part of Ursa Major, asterism in Ursa Major. But the Lynx, you can see it's kind of like wanders along by itself. And,
no real bright stars.
There's nothing, no bright stars in it. There is that one object that we cover. We talked about it a long time ago.
How do we find it then if it's so hard to find?
I would start with Castor.
Okay.
Which is easy. It's a naked eye star. It's the most northern of the 2 stars. You've got Castor and Pollux.
Okay.
So you start with Castor. Castor's actually, if you're at Castor, take a look at it with your telescope. It's a pretty double. Nice, pretty double.
Nice.
Then kind of slide over to the west. Okay. And unfortunately, by the graphics there, it shows as west because the whole field is twisted in there.
I know.
It's actually 7 degrees north of Castor and a little bit east.
Okay.
And so,
you were mentioning these 3 stars. Was that this object?
There's 2 fairly bright ones there that point right at the globular cluster. It's called NGC 2419. Mm-hmm. It's also called the Intergalactic Traveler because it's at 270,000 light years. And in the old days, they thought that globular was wandering between the galaxies, that it got thrown out and, wasn't really bound. But now that we understand more about our galaxy and dark matter and all that stuff, it turns out that it's close enough in so that the Milky Way is actually bound that globular cluster. And it's really gravitationally bound, by the Milky Way. It's a member of it. It's not wandering like a stray dog through the neighborhood.
Now, these 2 stars are the ones that we see in this image here, aren't they?
Yeah. You can see how they're nice and bright. Mm-hmm. They're ones actually that when I have my 750 binoculars and I look up there, I see those, and I know I'm in the right spot. A lot of times, I think I've actually managed to pull that. see something faint there in my 750s under, when it's overhead. And, it is really faint. It's
Okay.
magnitude 10.4. It's about 4.6 arc minutes across. So it's a fairly small object.
So this
So
is like a
it's good.
telescope object. This is not a binocular object.
Yeah, it's not something you have to know where to look. And so, if I'm starting out to actually find it, I would pull out my Sky Atlas, like Sky Atlas 2000.0,
Okay.
and then actually star hop with my binoculars. I would start at Castor, and I would just kind of jump along. There's like a pair of stars just over, and I would go for that. And then I'd probably go for that next bright one. And then I would drop down, make sure there's got a couple curved underneath it, and just drop down. Yeah, what they call star hopping. It's been something I've done all my life. I've never had a computer to guide me.
Got
And
it.
the nice thing about star hopping is you do learn the sky really well.
Yes,
over
yes,
time.
you do. Nice.
And so, and it turns out that this globular is one of the farthest ones that you can see with an 8-inch scope.
Oh, wow.
So that's, about the only standout deep sky object in Lynx. There's some little faint galaxies, but there's nothing other than that's, worth bragging about.
All right. Well, before we go to the last constellation, we had a question about the Milky Way. If we could, whoops. Hi, Brian. Hang on a second. Sorry about that. Wrong camera. So we had a question about the Milky Way, and the question was, oh, now I can't find it. Where did it go?
Yeah, so the question was, is the Milky Way visible in the winter sky?
Oh,
Got it.
yeah,
Or the
yeah.
northern hemisphere?
It's actually the winter sky. It's really well visible. It's not as bright as the summer Milky Way, but yeah, there's the winter Milky Way that goes right by Orion through Cassiopeia there. It's just because we're actually the anti-center. It's not super bright as you would expect until you start getting down in like Puppis, starts getting brighter. But remember last month when I was talking about the zodiacal light, how it's like a triangle that comes up out of the west of a yellow glow due to the dust in the solar system. Usually it points up towards the Pleiades. The Milky Way galaxy is just above that as it goes by, and you can compare the colors. The Milky Way will look white, where the zodiacal light will look yellow. In fact, there you can see part of the zodiacal light in the Pleiades there. See how it's got kind of like a yellowish twinge to it, heading up towards the Pleiades. But when you look straight up from the Pleiades, you can see the Milky Way through there. And so, it's definitely, you can tell the difference. When I'm out at Navajo Flats, I see the Milky Way as white, and I see the zodiacal light as yellow because it's reflecting the light from just our sun, which is a yellow sun, where the Milky Way is made up of a little bit of everything, ends up being pretty well white, and that's why they call it milky.
Yeah,
And,
if we look over on this part of the sky, we don't see any of that.
Yeah, in fact, right now, the springtime, we're getting into what they call the realm of the galaxies. We're getting away from the Milky Way, and, we're looking out into intergalactic space big time, and there's a lot of galaxies out there that you can see. And so actually the summer and the winter is when you get your best view. If you're patient, you stay up a bit later, eventually the Milky Way will rotate up and you'll see more. But you should be able to see the Milky Way almost on any night if you're patient enough. Either you catch it early in the evening, or you stay up way late, like 3 o'clock in the morning, and get a nice view of it.
Yes, very true. All right. Well, thank you, Kent. Do you want to go on to our last constellation?
Yeah, let's go on to Ursa Major, the Big Bear. Again,
Right.
that's a really old constellation, ancient Greek constellation. I picked objects that were near the asterism, which is the Big Dipper, because everyone knows the Big Dipper,
See if I can get it in. Do you
or
guys see
hopefully
the?
everyone does.
All right, so everyone, go ahead and point to the Big Dipper right now. Here, I'll give you the full screen. What do you think before Kent starts talking about it? Do you see it anywhere? Look maybe in the top of your screen. Do you see it? I know it's a little hard when it's flat like a computer, but you see it up here? All right, so the Big Dipper, that's not the constellation, is it?
No, it's actually part of the constellation, what they call an asterism. It's a grouping of stars. Actually, Ursa Major is really good sized, as you can see by how far it goes out. But those are the easily seen bright stars, are the big, the Big Dipper stars.
Mm-hmm.
And so almost anyone, I learned it as a child. I think my dad showed it to me. And that was about the only thing I did know in the sky that was correct. When I was like in high school, when I first started learning, that's all I had was the Big
Just the
Dipper,
Big
and
Dipper.
that was it.
And
no
now
one in the family knew anything, and so it's kind of like I had to teach myself.
Yeah.
So that's when I got the H.A. Ray book and started working. But we're going to go for 4 objects that are really near to the Big Dipper stars because they're easy to find.
Okay.
So the first one is a face-on galaxy called the Pinwheel Galaxy, or M101. And there's an easy way of finding it. You start out with Mizar. Remember Mizar? It's like the middle star in the handle of the Big Dipper. And they're actually, what you see naked eye is Mizar is the bright one, and then Alcor is the fainter one. They're not gravitationally bound. They just happen to be close to each other. But Mizar itself, under a telescope, breaks up easily into a nice pair of white stars. And so that's a good starting place to get to this big galaxy. Start at Mizar, and then you can see there's an arc of 3 stars out there that you can follow downward. And then you just kind of drop straight down, and boom, it takes you M101. M101's out there a ways. It's 21.8 million light years. Has a visual magnitude of 7.7, so definitely a binocular object. Size is about 29 arc minutes by about 27 arc minutes, and it has a diameter of 184,000 light years. So it's, getting close to twice the size of our galaxy. So It's a big face-on galaxy. It was found by Pierre Mersenne, a French astronomer, on March 27, 1781. He was a good friend of Charles Messier, so Charles Messier would include his observations. Actually, he'd go out and look at it first, and then he put it into his Messier list, but he always gave him credit for the discovery. And this one is also a neat, I don't know if you can get a nice blow-up image of it, but it's got like 9 NGC H2 regions in the arms. And that's kind of like you can see some of the knots in there. The Peters picture, there's some faint pink knots in there. And I remember taking my C8 and using the O3 filter on the eyepiece, and I would blink that galaxy, and those knots would get brighter. And that's due to the doubly ionized oxygen in those starbirth areas. So, yeah, M101's loaded in the arms with a bunch of star
here, I have
birth
something.
areas.
Yeah, actually, I have a picture of them labeled here. Hang on, let me grab it for you. Let's see if I can do this real quick. It looks like...
Now, it's kind of just cool to think you can actually see an H2 region in a galaxy that far away.
Mm-hmm. Yeah, here, I put it right on top.
There you go. Yeah, you can see there's a bunch of them there. And a bunch of them have NGC numbers, which means some guys noticed that these are knots, or they thought they were separate objects, which they kind of are, but they belong to M101. But they got cataloged, and you can see there's quite a few of them. In fact, there's 9 of them there.
Mm-hmm.
And so if you're ever out looking at M101, you've got a telescope there, an O3 filter or a UHC filter. Give it a try and see if you can get them to blink.
Now, what do you mean by blink? So can you describe
okay,
that?
Blinking is you throw a dark cloth over your head, you have the filter, you look through the eyepiece, and you move the filter between your eye and the eyepiece.
So it's not screwed into the bottom. You're holding the filter.
Yeah, you don't screw it in because you can't see the blinking effect if you screw it in.
Right.
You know, you move it and you look through the filter, and if the little area gets brighter, you move it away, you can see it gets fainter. You move it back, it gets brighter. You move away, it gets fainter. So that's what blinking is, and it's really useful for finding small planetary nebula. And an O3 filter works excellently. Also, a UHC filter isn't as harsh. O3 filter pretty well blows away everything else. It's super reflective, where a UHC filter has a wider bandwidth, and it doesn't obliterate the stars as much as an O3 filter. So a UHC filter will work just fine also. But that's one neat aspect about M101.
Okay, great. Now, M109, where would I find that?
Okay, you see the bottom of the dipper, the bowl, the bottom of the bowl. Pick the star nearest to the handle.
Okay.
And if I remember right, that star is Gamma.
Yes, you do remember right.
Gamma is really close. I mean, it's only located about or I say the galaxy 109, M109, is only about 38 arc seconds southeast of Gamma. And there, I can see it on there. You can see it's really close. So if you have your binoculars, you might want to, you can at least recognize those 3 stars in a row off of Gamma and hit the middle star and just go around the field. So that's how I would star hop to that.
Okay, great.
And so it's pretty easy being close to, Gamma Ursa Majoris. Distance-wise, it's out there. It's 67.5 million light years out there. It's a barred spiral galaxy, has a visual magnitude of 9.8, a size of about 7.6 arc minutes by about 4.7 arc minutes. And this is another one discovered by Pierre Mersenne, the French astronomer. He discovered it on March 12, 1781. And it's got a diameter about 137,000 light years. So it's, bigger than our galaxy, which is roughly about 100,000 light years, but smaller than M101. And it's actually one of the faintest Messier objects. Its arms are barely visible in a 14-inch scope.
Oh, wow. Okay.
So that's the specs on there, but you can see how close it is to the bottom of the bowl. So
yes, you can.
It's kind of like a gimme. It's an easy one to get. So
it is.
I tried to pick objects that were near the bowl so people could find them easily.
Speaking of which, there's an owl hiding in here somewhere.
Yeah, we've got the owl. That's the other one where you start at the other star. I think that's Beta there.
Yes, it is.
And there's a planetary nebula. You kind of go. What is it? Would it be? Is it westward, or I get mixed up on directions? Let's see. It would be 2.3 degrees southeast of Beta Ursa Major or Majoris.
So we're right in this.
And that would be the owl. In fact, I can see it there because of the color difference. You got that kind of greenish or bluish green.
Yeah.
That's the owl. And the reason it's called the owl, you see those 2 dark areas
I do.
on either side of the central star?
Yeah.
Lord Rose gave it the name the Owl Nebula because it kind of reminded him of a face of an owl. And he was using a 6-foot in diameter mirror made out of speculum metal from Ireland.
Wow.
And he could see the 2 dark areas in there, and he just thought it was a good nickname. So it's I think it's from the 1860s. So it's got a real history to it for the owl. The owl is out there a ways. It's out there, not like the galaxies, but it's still 4140 light years, so almost 4200 light years out. Visual magnitude is 9.9. Diameter is in arc seconds. It's 170 arc seconds, which would be about 3 arc minutes. Most planetary nebulas, you describe them in terms of arc seconds versus arc minutes. Again, this one was discovered by Pierre Mersenne. He discovered it on February 16th, 1781. It's visible in an 8-inch scope as a diffuse disk. You can actually see the disk quite nicely. And again, it's about 2.3 degrees southeast of Beta Ursa Major.
Okay, hang on. I'm getting there. There we go. So if we go, back to Beta here.
Yeah, that's Beta Ursa Major. So you just kind of slide along on the underside of that and go a little bit south. In fact, those stars there, if you've got a star chart, it makes it real easy to star hop. You just kind of jump along those. There's, binocular-wise, those stars will show up. So,
yes.
And you can see there's like a pair between the owl and this other little galaxy, and that's our next object, which is M108, which is an almost edge-on galaxy. It's 46 million light years out there, and we stumbled across the nickname I'd never seen before, where it was called the Surfboard Galaxy.
Yes.
And when you look at it, yeah, it kind of looks like a surfboard.
It does look like a surfboard.
And so I thought that was pretty cool. I've never heard of that nickname. I don't know where it came from or who came up with it. And it's getting harder to find out who comes up with nicknames, because it's easy when it's in a magazine or a book, but when it's on the internet, who knows where it came from?
That's true.
Unless you can get someone to fess up and tell you where they originally put it, you have no idea trying to trace these things down, where it came from.
Yeah, that's true.
It's magnitude 10.0 for visual magnitude, has a size of 8.7 arc minutes by 2.2, which translates into about 100,000 light years in diameter, which means it's roughly the size of our Milky Way, and it's only 8 degrees from being edge-on, so it's pretty close to being edge-on. And again, this one was discovered by Pierre Mersenne on February 19th, 1781, and it's about 45 degrees northwest of M97. So the two are fairly close to each other.
They are.
It's also about 1.5 degrees east-southeast of Beta Ursa Major. So if you're going to go for the owl, you might as well take a look at M108 also, because I usually kind of move towards that star between the two of them and, see that one and then slide over from there.
Now, I have a question for you. What kind of color would you expect to see for the Owl Nebula when you're looking at it with your 20-inch?
Yeah, in my 20-inch, I don't see any color in it. Okay. It isn't bright enough to give you color. At least my eyes aren't good enough. But when you do see color in planetary nebula, you get a range. Some people see them as blue. Some people see them. I see color. In most cases, it's really, really strong green, like Kelly green.
Okay.
And, actually the true color, which is probably shown there, is kind of a turquoise or blue-green.
Yeah.
It turns out if you look at the frequency chart, most of the light is around 5,000 angstroms. And 5,000 angstroms on a color versus angstrom chart for light turns out to be blue, green, or turquoise. So when we're doing a star party like the ones we used to do at the KOA camp area, there's a lot of kids there, and I would ask the kids, like, what color do you see for, like, the cat's eye? And to me, it's like super green. Some, adults see blue, but kids, a lot of times call it blue-green or turquoise, something like that. So
Really?
their eyes are young, and I get the feeling as you get older, you get a little bit of drift one way or the other.
Yeah.
And, but the true actual color on most of these is blue-green.
That's interesting.
And so there's been arguments. It's kind of funny. Some of the arguments have been, people that see it as green. One argument was, well, you're an old geezer and you've got cataracts and your lens have turned yellow.
Oh,
And so,
no.
Yellow and blue gives you green. And so, there was all these different arguments, but I think it's a physiological thing that happens as you age, that you don't stay right on. And you're right at the edge in a lot of these of just barely getting enough light so you can activate the, the rods.
Mm-hmm.
No, it's the cones. The cones give you color.
Yeah.
The rods give you black and white vision. Your eye actually has two different sensors. Where you actually stare at something gives you color. So if you want to see color, don't use averted vision like we've been telling you to do over and over and over again. If you want to see color, you stare right at the object and use those cones because they're at the center of your focus. Mm-hmm. If you want to go after really faint features, then you kind of look out of the corner of your eyes, what they call averted vision. Mm-hmm. Don't stare at it. Just kind of look off center, and it becomes second nature with enough practice, so you can switch back and forth. But it's just due to the physiology of the eyeball, where you've got the cones at the central focus, and you've got the rods that surround them, and the rods give us our good black and white vision for when you've got low light conditions.
Yes. Awesome. Thank you. Let me go back over the 4 objects just real quick. You guys ready to do a quick review of the Big Dipper? Okay. So can you find the Big Dipper on the chart here? Okay. So it is right here. You can see the 4 stars that are in the bowl, the 3 in the handle. So the first object, M101, we went to the middle star. Okay. So I'm going to zoom in. You tell me when you see M101. You ready? Okay, so we're just going to go here. Remember how Kent was talking about the stars that lead to it? Remember? You can see it here. Oh, do you see it yet? Do you see it? Yep, it's right here, isn't it? Okay, great. So that's M101. So again, it's from the Big Dipper. We're just taking that middle star you can actually see, and if you've got good eyes, you can see it. I actually took a picture of this last night with my Nikon camera. It was the very first picture I've ever taken. It's brand new. I just got it. And in that image, the stars were so sharp I could actually separate these two just with a regular lens on it, not attached to a telescope. So you're going to drop down and then you'll see M101. Okay, M109 is not here. M109 is, you're going to look in the bowl, okay, and you're going to look at this star. Now you tell me when you can see M109. Okay, so how far are we going to be looking for it? Can you see it yet? I know, Kent, you can see it. I'm not talking to you. I know. I'm keeping my mouth shut. Here it is right there. Do you see it? Okay, now keep your eye on this one. I'm going to back out. You see how close it is in the bowl? So it's right there. It's really close. So if you just take your binoculars and you just kind of graze around this area or cruise around this area, you'll find it. And actually, you won't find it with binoculars, will you, Kent?
If you had really good eyes and maybe 1050s and it was overhead and you're out somewhere dark, you might have a chance.
Okay.
It's much easier to have like an 8-inch or 6-inch scope and go after it.
Okay, great. And then the last ones were closer to this star. Okay, so we're just I'm going to zoom in. You tell me when you see it so you can kind of get a feel for it. Okay, so we're looking for the owl and we're looking for a galaxy. Oh, you can see the owl here. So you notice what the relationship is here. If I put the lines back in, what the relationship is from the bottom 2 stars of the bowl. You can kind of see it's much closer to this star, and we're just going to look in this area here, and we can see the owl is here, and we have M108, which is right there.
Yep.
Awesome! Yay! We did it! Woohoo! So how was that? Is that something that you feel like you can go outside, look up, and find a couple of these things? Absolutely. And, Kent, Kent's been doing this for a long time, but like he said, at one point he only knew the Big Dipper. So every night, if you just go out and you start to recognize those star patterns, just a little bit more, a little bit more, a little bit more, and over time you'll get to build that all that knowledge up. Brian, you have something for us as well, don't you? Let's see.
I do indeed.
Yes, you do. Let me show you
Yes,
a
I
picture
do.
of Brian. This is Brian with his telescope. He's been doing a lot of stargazing with us. He's got binoculars. He took this image, which is amazing. So, Kent, what is this image of here?
A couple things there. That's the furthest east star in the belt of Orion is the bright star in the center.
Mm-hmm.
To the right of it, you can see the horse head there. That little dark area, that's the famous horse head. And then right below that bright star is what they call the Flame Nebula. And again, you can see another dark lane running right down the center of the Flame Nebula. And I can see that in my 8-inch.
Wow.
Can't see the horse head in my 8-inch from, here. I did see a hint of it when I was in Western Australia with the 8-inch. But with the 20-inch, I can pull it in and actually see the shape of the horse head. So that's my limitation. It takes like a 20-inch for me to pull it in.
Nice. Awesome. Thank you. Brian, let's see. Let's go over to you. You have something to share.
I do. I'm excited to announce our new online star.
Our online store,
I guess.
Let's try that
Easy for me
again.
to say. And on our store, we have coffee cups and t-shirts, sweatshirts, even travel mugs, and all of them have photos taken by club members. So each one features a certain deep sky object, and these photographs have all been taken by club members. So what we've done is we've set up centralcoastastronomy.org/shop. Type that in, and then it'll take you straight to the page, and then you can browse through all of it. What you'll do is you'll first see the name of the object and who took the photo. Once you click on it, then you'll be able to see the different options that are available for mugs, t-shirts, and things like that. So go and take a look.
Awesome. Thank you. And it's wonderful to have our astronomers provide the images that you get to pick on the product that you want. So you can have a shirt, you can get your mug, you can get all of them. And then you could join us when we do stargazing. So awesome. Thank you. Brian, do we have any other questions that we want to ask Kent before we close for tonight?
Let's see. I'll just double check really quick just to see if there's anything else.
All right.
Well, we did have an interesting question. Person was asking, if we are looking at an object, let's say if we're looking at a planetary nebula, and then also if we're looking at a galaxy, does the color or general colors that are visible change over time?
Actually, for galaxies, it's going to change enormously slow. Now, we're talking about if you look at it year to year at the same position in the sky. I would say the color might change over billions of years where, the stars age, that sort of thing. I mean, so, essentially for all practical purposes, galaxies stay the same. Now, planetary nebula are actually expanding. And so the colors will, and we're talking on the order of maybe from 10,000 to 40,000 years, which is like an eye blinking compared to a billion years. But planetary nebula expand. So when they're small, you can actually see color. When they expand out, they'll fade to more of a white and eventually become invisible because they expand out so far, the gas and dust gets scattered in with the rest of the galaxy, and eventually it'll be raw material to form another solar system a billion years in the future. Does that make sense? Or?
Yes. How does that sound to you, Brian?
Yes, that very much answers the question. Thank you.
Awesome. And we actually have a number of members here. I'm kind of cycling through them. You can see Lee Coombs here. He actually has a video we just posted on our website where he gives you a little 5-minute tour of his observatory that he built and where he has done astrophotography for the past 25 years. Lee has over 1,000 astrophotography images that he has had published in different journals, magazines, books, you name it. So, and Lee is going to be doing a special class just for us on how to look at the moon. So, and we'll let you know when that comes. We also have another astrophotographer who's a member. He has been doing a bunch of wonderful work as well. His name is Nico. And so you can see also very similar to Brian's image here with the Flame Nebula and Orion. Looks like his sword is going this way, doesn't it? Can't.
Yeah, the sword's at the far end there. I can see the horse head.
Yeah,
But yeah, there you've got it. That little bright area over to the right and up is actually the Orion Nebula.
And do you recognize? Oh, here it is. Here it is. Here's the three
stars.
stars.
This one is actually Barnard's Loop, where you can see the belt there you've got that curve. That is a hard thing to see, the Barnard's Loop. But you can see the three belt stars, and I can't see the flame or the horse head, but you put the cursor on it, and then down below that is where the Orion Nebula is. So, and you can also see Rigel over there on the lower right. So that's a real nice shot. I mean, it ain't easy to get the Barnard's Loop in there. Although there are some people that claim to have seen it naked eye. So I think they were actually holding up like an H beta filter in a dark site, and then looking through the H beta filter with their naked eye to have the Barnard's Loop pop in. Until you really pull it off yourself, you sometimes wonder whether they can really do it. I mean, it's like seeing M81 and M82 naked eye. Those. I can barely see them with binoculars.
I was just gonna say, I think I've only seen them with a telescope.
Unless they're somewhere on a mountaintop where there's no cities within 500 miles, and it's good and dark and steady. Maybe down in Chile or somewhere like that where they've got excellent seeing, or up on Mauna Kea in Hawaii where there's super excellent seeing.
Yeah, that's true. Well, for those of you who have been asking a lot of questions about equipment, there is the last page of the handout. These are the recommendations from our club for beginner telescopes, binoculars. So just take a look at that. If you have specific questions, you can always let us know. You can write to questions@centralcoastastronomy.org, and we would be happy to answer your questions for you. And let me put that back up. Did that come up? It did. So you can ask any questions you like. Our website, just so you know, it's www.centralcoastastronomy.org. And if you enjoyed tonight's presentation, maybe make sure you like and subscribe our YouTube channel, and so you'll get notified about when we do these again. Brian, did you have any other? Oh, did you want to? I noticed people are asking when we're going to be doing live presentations. Live in person. Thank you. Live in-person Stargazing. We do not know that information at this time. So at the moment, we are planning to have another Stargazing event in May that is online. And we'll probably have more information within the next month or two. So we just don't know. The best way to get informed and stay informed is to go to our website, which is centralcoastastronomy.org, and sign up on our email list. And then whenever we have Stargazing events, we just send out an email saying, hey, we're going to be here on this Saturday. And that's really the best way to do it. Any other last minute announcements, Brian, before we wrap it up for tonight?
I think too, if you are on Facebook, you can follow us on Facebook as well, and we'll make announcements there, but we'll definitely send out any updates, not only on our email list, but on Facebook as well.
Excellent.
So you can follow us there.
Okay, great. Well, from our club to you guys, thank you guys so much for joining us. Kent, thank you again for sharing your passion and your knowledge, which is extensive, incredibly.
Oh, thank you very much.
Awesome. Well, thank you, everyone. Brian, thank you for joining us and for being with us tonight. Thank you. All right, everyone, and we will see you next month for our next Stargazing event. Have a good night. Go outside, go look up, and share it with others. Good night, everybody. Bye-bye.
Goodbye.
Goodbye.
Bye.